Hello children, today our topic is electric current and its effect. Before starting this, in class 6 you must have learnt about electric current. What is electric current? Flow of charges. These charges they flow where? In the wire. And children, you have also learnt about electric circuit. Electric circuit, what is electric circuit? The arrangement where an electric current flow in a conductor when it is connected to a source of electric current is known as an electric circuit. Okay, and components of an electric circuit. First we are going to discuss electric circuit because current is flowing in this electric circuit. What are the components of electric circuit? The cell or battery. This is the source of current. This longer side is plus and the smaller side is minus. This is the source of current and the current is flowing in the wire. These are these wires, they conduct current. So they are what? Good conductor of electricity. And this is appliance which we want to use with the help of this electric current. And children, for on and off we require switch. So these are the components of the electric circuit. And children, when two or more cells are there, this setup is called battery. Single is cell. When two or more cells are there, combination of two or more cells, it is called battery. And appliances, what? Like here appliances, bulb, we can use any appliance. Like in home we have TV, fridge, all these are what? Appliances. These are the, it is very difficult to draw the appliance and wire and the cell and battery. So we use symbols. These are the symbols of these elements. This is the symbol of battery, this is the symbol of cell, this is the symbol of switch, open switch, and this is the symbol of closed switch. This is bulb. When current is on, the current is switch is on, current is moving and the bulb is glowing. So these are the elements of the circuit. Now children, and this is called circuit diagram. With the help of these elements I have drawn the diagram. This is called circuit diagram. Now I am going to tell you about the potential difference. Here only I am going to tell you what is potential difference. Like we have cell. We have cell and accumulation of charges are what is the movement? Just you are seeing from positive side the current is moving, and it is going to the negative side. So accumulation of negative charges more here this side, because this is chemical is filled in this and that produces charges. The negative charges are there and positive are here, more. Now which charges move and which brought current? That is electron. What is that? Electron. So accumulation of electrons are more in positive side, less here. So these charges they move from positive side to the negative side. So potential difference is what? The movement of anything, from positive to from higher concentration to the lower concentration. So here a higher concentration is which side? Positive side, and lower concentration is minus side. So charges move from positive to negative. And children, you will learn about two currents, electronic currents and conventional currents. These are conventional currents. And you are going to study about electronic currents and conventional currents in class 8. Now we are going to discuss effects of electric current. This is electric current I told you. And now what are the effects of this electric current? First effect is heating. Okay, first effect is heating effect. Heating effect, children, all conducting wires. Okay, when the current is passing, like I am drawing two conducting wires, this is of copper and this is of nichrome or tungsten. Okay, current is passing from both the wires, but we find this wire heats up very little, बहुत कम, very little. Okay, so means if it is heating up very little, its resistance is less. Resistance is less. Okay, and this we find the same amount of current we are flowing from this nichrome, it heats up like more. Okay, so the heating effect of electric current is used. This heated up more. So the heating effect of electric current is used in a large number of domestic and industrial appliances. Example, room heater. Children, you have seen in the room heater, rods are there and this nichrome wire is wrapped around this. So when the current passes, what happened? It resists the current. Why it heats up more? Because it resists the current. Okay, resist the current and heats up more. And this heating we utilize in these gadgets like room heater, water geyser. Okay, so we will say that nichrome, and one more I am telling you, tungsten. Tungsten, they are high resistant wire. They stop the heating like current and they heat up more, and we use their heating effect in different gadgets. Like tungsten we use in electric bulb. Children, you must have seen in an electric bulb, filament is there. Okay, in the bulb, and this glows, this heats up and it becomes red hot, and this heats up the gases which are present in the bulb, and because of the heat these gases also glow and it gives us light. I told you in heater, in blower also this is used. In iron, electric iron, the element. Okay, we will if we open and we will see, you ask your like an electrician that show me, you can find these nichrome wires are wrapped like this. Okay, and when this heater or press heats up and we utilize to iron the clothes. In water geyser also this is used. Hair dryer, so wherever we want heat, so we use this heat which is produced by electric current, so we call it heating effect of electric current. Lighting, just now I told you in bulb, second effect, lighting effect. All the incandescent bulbs and tube lights, they are using the lighting effect. Okay, I have told you already, tungsten that heats up, and same way in tube lights and CFL, LED, in all this heating effect, lighting effect is used. Lighting effect of electric current is used. Okay, lighting effect, abhi I told you about the tungsten. Okay, this is what? Tungsten filament. When the current passes, this is conductor, the current passes through this filament and it heats up, and when it heats up, it heats the gases around it, and these gases after heating they glow, and because of this we get the light from the bulb. So this is what lighting effect of electric current. Now children, heating effect we also use in fuse wires. Fuse is a safety device. Nowadays this fuse is fitted in all the devices. Okay, like in our mixie, TV, so that this protects the devices. And also you have seen in our houses, in the mains, porcelain box is there. That is also, what do we call that? Fuse. What happens sometimes, the current which is coming from the pole, maybe like fluctuation is there, like sometimes it comes, too much current is coming. So that time what happened, the wire inside it, okay, it is bringing current from outside. So this wire heats up and it breaks. And it does not allow this uneven heat, or we say more current to the house, so that this way it protects the gadgets of our houses. And this wire is made of a special wire, like I told you, nichrome there. Nichrome is an alloy of nickel and chromium. Here this wire, fuse wire, is made of alloy of lead and tin. Lead and tin. Okay. And what is the specialty of this alloy? Its melting point is very low. Melting point is low. So when current will pass, the current will heat up the wire. Because of its melting point low, it melt, and what will happen? It will break, and it will protect our device from the heavy flow of current. MCB is also there. In MCB, this breaking does not take place. Full form of MCB is miniature circuit breaker. It is a switch that automatically stops the current in a circuit if the current in it exceeds, okay, the specified maximum limit. Okay. Now next effect we are going to discuss, that is magnetic effect. Magnetic effect. Children, like current is flowing, and if we will keep any compass needle here, so we will find this compass needle deflected from its direction. Okay, so it means that the current is affecting magnetic needle. Okay, so by this we come to know it is affecting the magnetic needle. This experiment was first performed by Ørsted in 1820 to show the magnetic effect of current, and what he concluded, that wire carrying an electric current possesses a magnetic field around it. It makes the magnetic field. Okay, any magnetic like needle and compass, if we will bring, that is going to be deflected. Okay, the current carrying wire is not strong enough. Sometime what happened, the strength of magnetic field depends on what? Current. Suppose single cell we are using, then the magnetic field is less. If we are going to use battery, then what will happen? The magnetic field will increase. So magnetic field depend on magnetism. By electric current depends on current also. Now we are going to discuss what is solenoid. Children, solenoid is nothing, only it's a coil of, like we take the wire in, okay, and we coil it. Many turns are there and we are going to call it solenoid. Okay. A solenoid is a cylindrical coil of wire. When a current flows through it, the solenoid behaves like a bar magnet. Okay. When we are going to pass the current, okay, it is going to behave like a magnet. We can do one experiment also. What things are required to improve the strength of this solenoid? The strength of solenoid can be increased by increasing the number of turns. First thing. First is increasing the number of turns. Second is increase the current. As I told you that if we will increase the current, the magnetism would be more. Okay. Increase current. Increase current. Third is winding the solenoid. This winding. Okay. This winding we must do around the magnetic material. Like we will take any magnetic material like soft iron. Okay. So we use any magnetic, we do the winding around any magnetic material. Then what will happen? Its magnetic effect would be increased. Okay. So these three things are very important for the magnetic effect of electric current. Okay. Now you can make this in home, this electromagnet, and this setup is called electromagnet. You can make this. Now we are going to discuss uses of electromagnets. So children, we are going to use uses of electromagnet. Electromagnets are used in a number of electrical appliances such as electric bells. This I have drawn for you. And electric buzzers, they are used in electric motor, which find wide application in fans, washing machines, air conditioners, refrigerator, etc. Here we are going to discuss the working of electric bell, how it does with the help of electromagnet. Just you see in the figure, a simple electric bell, it consists of an electromagnet. This is electromagnet. The whole setup, this is called armature. Okay. And this is electromagnet. This is spring. This is iron rod. Okay. And this is very important, contact pin. This is hammer, this is gong. How this electric bell work, I am going to tell you. When the switch is on, this is switch. What happened when the switch is on? The current start flowing from positive to the negative side. Okay, as the current reaches to this is soft iron, electromagnet I told you. And what happened when the current passes through this soft iron, it starts behaving like magnet. When it behaves like magnet, it is going to attract this iron rod. Okay. This iron rod, when it shifts this side, what will happen? It will beat the gong. It will beat the gong, and what happened? The sound will produce. But what happened when this whole portion is shifting to this side? It detaches from this pin. Okay. As it detaches the pin, means circuit is off. Circuit is off, and what happened? The magnetism, there is no more magnetism. It loses the contact with the this armature loses the contact with the pin. Again this setup armature will come back to the pin. Again when it is touching the pin, current will pass, and what will happen? Electromagnetism take place, and what happened? This will shift that side, and again it will beat the gong, hammer the gong. This causes the electromagnet to lose. I have told you again, this what happened? This causes the electromagnet to lose its magnetism, and the armature spring back to original position to close the circuit once again. Current flows again and again, and the cycle repeats. This thing keeps on repeating itself till the current is switched off. Okay, so this is the working of what? Electric bell. Thank you, children.